Right, thanks so much for inviting me. The person who was actually going to stand here is Corinde Wiers, who's a professor for experimental psychology in the Netherlands. And we used to be collaborators when I was still a PhD student in Germany. And he also turned out to be my faraway cousin from Holland. So he said, "Oh well, you're a Wiers too. You can present it for me. You can see it." But I'm actually mainly presenting my data. So right now I work at the NIAAA in Bethesda, but I mainly talk about my findings from my PhD in Germany, namely the neural effects of cognitive bias modification training in alcohol addiction. And a small background in alcohol addiction. Well, people start drinking for many reasons, of course, because they really like the feeling or they want to get rid of a negative feeling like anxiety. But over the course of alcohol taking, there's this central paradox in addictive behaviors, namely the continuation of drug use despite negative consequences. And you can see this from the very high relapse rates. So in alcohol addiction alone, over 80% of people who explicitly say they want to quit cannot. They find themselves over and over again to drink. And in the more cognitive neuroscience literature, there's this dual process model of addiction that on the one hand, if alcohol or patients with alcohol use disorder, if they're exposed to cues that remind them of alcohol, their more overactive reward system comes into place, mainly in the ventral striatum, medial prefrontal cortex, and amygdala, whereas there's this proposed less active reflective system, mainly in the dorsolateral prefrontal cortex. And if you see the empirical evidence for this dual process model, just behaviorally, if you confront alcohol patients with cues that remind them of alcohol, they say, or roughly say, yeah, this induces craving in me, but this finding has been relatively inconsistent, and in the 90s this was already that they thought, well, probably craving is more an unconscious process and cannot be reported verbally. So in neuroimaging studies, it has been shown that if you just passively view alcohol cues in people who like alcohol or people who don't like alcohol or people with an alcohol use disorder, that alcohol cues versus most of the time neutral or soft drink cues, that areas related to reward are more active, whereas dorsolateral prefrontal cortex has been shown to be less active compared to controls and compared to neutral cues. And third, in experimental psychology, there's a wealth of literature on automatic biases. So in the one bias that has been measured is the attentional bias for drug use, and also the approach bias for drug use. And the attentional bias for alcohol can be measured with this visual probe task. So a participant just sits behind a computer and they see two cues, non-alcohol cue and an alcohol cue, and there's a dot below it, and you just have to press left or right depending on where the dot is. And it has been shown that when the dot is under the alcohol cue, that alcohol use disorder patients respond faster to that one because they already had an increased attention towards these alcohol cues. And another bias that has been studied more recently is the approach bias. On this approach avoidance task, you have a joystick and a computer, and the instruction for participants is that if you see a picture in or a landscape format, then you push as fast as possible with this joystick, and if you see it in portrait format, then you pull as fast as possible. But this is of course counterbalanced, and if for example, if you see a cue like this, you push it as fast as possible, and here you would pull it. And the task itself would also have a zooming effect, because otherwise you wouldn't find the approach bias effect, namely that if you push it away, the cue becomes very small, and if you put it towards you, the cue becomes very large. So it's a representation of avoidance and approach. And the approach bias is calculated by the reaction time of pushing minus pulling. So the larger this approach bias score, the stronger your automatic tendency to approach a certain cue type. And the first person who showed it in alcohol was Reinhard in Amsterdam, who showed that heavy drinkers show increased automatic tendencies of pulling towards these cues of alcohol compared to soft drinks cues. So a faster approach versus avoid those specific alcohol cues. And this has now been replicated also in alcohol-dependent patients, in smokers, marijuana users, and you also see it in heroin abusers. That was a study from China. Yeah, so for these, of course, not alcohol cues, but they're all drug-related cues. So marijuana leaves or just joints and so on are being pushed, pulled faster than pushed. So the research question that I worked on in my PhD thesis is, well, what are the neuroprocesses underlying this automatic approach bias for alcohol? And the hypotheses were that, of course, we wanted to replicate this behavioral finding of a larger or stronger approach bias for alcohol stimuli in alcohol-dependent patients, and also that this approach bias would be associated with increased reward-related areas, whereas less active dorsolateral prefrontal cortex. And what I did there in Berlin was inviting 20 alcohol-dependent patients into the lab and 17 healthy controls, and they're all matched for age, education, and handedness. So the only variable that they were different on was alcohol use. And we measured them in the 3D Tesla fMRI scanner with this approach avoidance task while lying down. Of course, you have to. For some people, they were a little bit too big, so we couldn't do this joystick experiment. But yeah, so participants were in there on the screen. They saw these cues and had to push and pull. And during these scans, we were just measuring their bolt responses. And the main measure of interest was, for both the reaction time and the bolt response, is interaction between drink type times movement times group. And the results show a replication of this behavioral effect, namely an interaction effect between this patient or group times the type of cue. And if you look post hoc, you see that the differences were mainly for the alcohol cues. So alcohol-dependent patients had stronger approach bias compared to healthy controls for alcohol cues. And also, if you look at the interaction of pulling versus pushing alcohol versus pulling versus pushing soft drinks, we saw that the right nucleus accumbens was activated and also the medial prefrontal cortex. But we didn't see any evidence for the amygdala in this group comparison. But in the reverse contrast, we didn't see any less active dorsolateral prefrontal cortex. And then when we ran a correlation analysis, we did see that only in alcohol-dependent patients who showed that the amygdala was associated with their explicit ratings of craving. So, summary of this first study is that the automatic alcohol approach bias involves the nucleus accumbens and medial prefrontal cortex, but we didn't find evidence for a less active dorsolateral prefrontal cortex, and we also found a correlation between amygdala activation and alcohol craving. So thus, we would suggest that there's a more active motivational system active for the alcohol approach bias, but no support for a less active control system. And here are the studies from Reinhard who come into place. Can this alcohol approach bias be treated? And he published a paper in 2011 on the clinical effects of cognitive bias modification training using this approach avoidance task. And this CBM, or cognitive bias modification training, in his trial, participants underwent 6 times 200 trials of this specific task, and the instruction was exactly the same: just push a horizontal cue and pull a vertical cue. But in the CBM version, the task was manipulated in a way that the alcohol cues were pushed in 90% of the cases, not 100%. So it was still relatively implicit that what they were doing, but still in the majority of the cases, alcohol patients were pushing away these alcohol cues, whereas in the placebo or sham condition, it was just the approach avoidance task with 50% pushing alcohol and 50% pulling alcohol all along. And the soft drink was then reversed for the cognitive bias modification. So in the training task, patients were just selectively learning to push away alcohol cues. And what they found, and what also has been replicated now, so in the first study, this was in heavy alcohol users, well, they found decreased approach bias scores. If you learn to push away and eventually you are being tested on this approach avoidance task, then you have lower approach biases for alcohol because you've just learned to push it away. And this also generalized to new stimuli. So if you're trained on, say, 40 cues, and on the test task you just show different types of alcohol cues, for example, this effect was still there. Further, in heavy drinkers, they showed lower alcohol consumption. So heavy drinkers were doing just one session of this training, and they showed that afterwards they were doing a beer taste test, and the drinkers just drank less beer after this training. But very relevant in alcohol-dependent patients or in clinical settings, it also lowered relapse rates up to 13%. So Reiner was the first one in 2011, and this was replicated in the same clinic. It was in the same clinic by Carolyn Abel and Mike Rink, which is now in preparation. Yeah, so I found it very interesting, and I went to Germany to actually answer this question: what are the neural effects of this bias modification training? And the hypothesis here was also a stronger decrease in this motivational system when alcohol patients were viewing alcohol cues after training versus before, and also in the training versus in the placebo training. And I specifically looked at the nucleus accumbens and amygdala because both these areas already showed decreases by various treatment studies. So I think Volseth-Klein was someone who did an exposure therapy in alcohol use disorder patients, whereas Snyder used a pharmacological agent. But at least these two areas were receptive to any change or to any therapy. So I used a very, very basic alcohol cue reactivity task, a block design, 6 blocks of alcohol cues. These are mainly German cues or popular German drinks, and the soft drink cues with some American influences too. Jack Daniels. So the design, patients came into the lab. We started with 36 alcohol-dependent patients and underwent this cue reactivity task. Then they went back into their clinic, and 18 patients underwent CBM training, and the other patients underwent this placebo training. And of course it was blind to them what they were doing, also blind to the therapist who actually gave these trainings to them. And they did this training for 3 weeks, and we used exactly the same ratio, so 90-10 versus 50-50. Then 3 weeks later they came back again for this cue reactivity, but instead of 36 we only had 32 because 4 people dropped out. So we had 15 versus 17 as a final sample, but they were still matched for all these measures. So the behavioral results, we did see trend-wise that in the CBM training the approach bias scores decreased, but there was not there are no significant interaction effect of time times group, and this may be because it's just such a small sample size. But on neural level, we found that that's the time point 1, that throughout the whole group there was increased activation in the nucleus accumbens and in the amygdala for alcohol cues versus the soft drink cues. And if you look pre and post, we saw a stronger decrease in the CBM group, which is plotted positively here, versus the placebo training group. So in the amygdala. So the amygdala, there was a decrease in activation over training compared to placebo, exactly. And also this decrease in amygdala activation correlated with decreases in craving responses. So it was actually a main effect of craving. Both groups after 3 weeks said, oh yeah, we crave alcohol less, which you would expect if they're also in other behavioral therapies. They also did it on the side. But only in the CBM group did this decrease in amygdala also correlate with decreases in craving. So a summary of these neural effects of CBM, we didn't find a behavioral effect, but at least we showed first evidence that the CBM can reduce alcohol cue evokes amygdala activation, and this correlated with craving. So cognitive bias modification may reduce the salience of alcohol cues, which may be a key underlying mechanism of its therapeutic effectiveness. But of course, this was the first study out there in alcohol addiction, very low sample size, and this needs to be replicated in much larger samples. We did also do a study in only 13 versus 13 CBM versus placebo, but there we looked at the pre and post activation of this approach avoidance task, and there we showed a decrease in medial prefrontal cortex activation, only in the CBM group and not in the placebo group. And this was associated with the approach avoidance score, so the bias itself, but not with craving. So conclusion, there's an overactive reward system involved in this alcohol approach bias, and we show first evidence that CBM can affect mesolimbic brain activity, and a reduction of this mesolimbic cue reactivity may be an underlying mechanism of this therapeutic effectiveness of CBM. And in the last few months, we finally have a Wiers and Wiers paper that's currently in revision. I still owe you the revision. But we just reviewed the literature on the neural effects of CBM, and until now there are actually only 9 studies in anxious behavior, only 2 studies in depressive behavior, and 2 of our studies in addiction, and they all have very small sample sizes, and the results are all over the place. But for example, Jennifer Britton, who's now in Florida, also showed decreased amygdala activation for emotional phases after CBM in anxiety, for example. So amygdala activation may be something that is involved in this. But yeah, we definitely need more replication, also in different study groups. The reason that we only did it in alcohol was that in Germany you're not allowed to do any human studies in illicit drug users, for example, so we have to stick to alcohol. But Reinhard also works on smokers, and he also showed that in a clinical trial with heavy smokers that there was also a decrease in relapse, but it's not out yet. Yeah, so The Economist was very optimistic about CBM may put the psychiatrist scouts out of the business. I don't think it would ever work like that, but at least it is a promising measure or a promising therapy that can actually tackle these unconscious processes in addiction. And many thanks to my previous PhD advisors, Felix Bermpel and Henrik Wouter, and my collaborator Reinhard Wiers. And currently I work in the lab of Nora Volkov, also for the last year. So she is an amazing mentor, and I actually started doing that research now, so, other than you, Diana. So thank you, and if you have any questions, let me know.